So what is the first step? Find acceleration. What is the, now you can combine these. What is the total mass? Total mass 6. And what is the net unbalanced force? 20 minus 10. 20 minus 10 is equal to total mass 6 into acceleration. Net unbalanced force is equal to total mass into acceleration. So 10 is equal to 6a. So what is a? 5 by 3. 5 by 3, correct? Good. 5 by 3. Acceleration is 5 by 3. How many of you got correct? 5 by 3. 5 by 3. Okay, good. Now find unbalanced force for 3 kg. For 3 kg, now you see, for 3 kg, what is the leftward force? 20 Newton. And 2 kg will push 3 kg right side, because 3 kg push 2 kg left side. 3 kg will push 2 kg left. So 2 kg will push 3 kg right. Okay. So I am considering 3 kg. So the contact force is right side. Contact force between 2 and 3 kg. Okay. Normal force between 2 and 3 kg is right side. And acceleration is left side. Acceleration is left side because the unbalanced force is where? Unbalanced force is where? Left side. So acceleration is where? Left side. So which force is greater? 20. 20 is greater because acceleration is left side. So 20 minus n is equal to ma. Now mass of 3 kg is 3 and acceleration, we know that acceleration 10 by 6. So 20 minus n is equal to 3 into 10 by 6. So 5. So n is equal to 20 minus 5. 20 minus 5, how much? 15. So contact force between, normal contact force between 2 and 3 kg is 5. 15, sorry, 15. Note down. Find acceleration, see the direction of acceleration, direction of unbalanced force. Unbalanced force is left because 20 is greater, 20 left is greater, acceleration is left. Now for 3 kg, 20 is acting left, normal from 2 kg will act right. Okay, 20 is left, 2 kg will push 3 kg right. That is the normal force. This is the push from 2 kg on 3 kg. It is a push force from 2 kg or 3 kg. Note down. So blocks are in contact. Blocks are in contact. So 3 kg pushing 2 kg left, 2 kg pushing 3 kg right. Okay, understood? Then greater force, acceleration is left, so 20 is greater force. So net force 20 minus n is ma. So mass into acceleration. Okay, then calculate n. So done. So what is the answer for normal force? 15 Newton, right? 15 Newton. 20 minus n is equal to 3a. A is 5 by 3. Okay, next. Now we can solve some questions on tension forces. Note down. Two blocks, so two blocks connected by string, connected by string. Now this string is massless. Okay, string is massless, inextensible. Massless, inextensible. Inextensible means the length is fixed, constant. Length is fixed. Like rubber band and thread. What is the difference? Rubber band and thread. Rubber band and thread. What is the difference? Rubber band can be stretched, elongated. So length can be more, length can be stretched, length can be stretched. But thread means length is fixed. So I'm talking about thread. So string means thread, inextensible, massless. Okay. So two blocks connected by a string. So let's solve some questions. So let's talk about horizontal surface first. So this is the horizontal surface. This block is M1. This block is M2. They are connected by a string. This is the string, okay? And you are pulling M2 right side using force F. So what if, on which block you are exerting force F? M2. So you are pulling M2 right side, but M2 is connected to string whose other end is connected to M1. So if now let's call these ends as 1 and 2 or 2 and 1, let's take. So the end 2 will move right side. So end 1 will also move right side. Correct? Like this pen. Observe this pen. If this end is moving here, so this end is also moving here. Correct? Both ends are moving like this. And it is attached here. So why M1 will move? Because of string. You are pulling M2 right side. So M2 is pulling the string and string is pulling M1. Correct? So these are known as connected system. They are connected. Like a train. Train is also like this. Engine is pulling next bogie. Engine is pulling next bogie. That first bogie is pulling second bogie. Second bogie is pulling third bogie. Correct? These are connected. Whole train is going like this. So, so now you see string. What string is doing to M2? It is pulling or pushing? Pulling, correct. Because M2 is pulling string right side, so string will pull M2 left side. And the same string will pull M1 right side. So free body diagram of M1, tension force T right side. For M2, tension force T left side and external force F right side. Okay, clear? So this is the free body diagram. Normal force also there. Normal force if you consider for M1, N1 is upward, M1G downward. And normal force for M2, N2 upward, M2G downward. Correct? So this is the normal forces. Okay. Surface is there. It is a smooth surface. Okay. Remember, I am not talking about friction. So it is a smooth surface there, frictionless surface. So normal Mg for M1 tension right side, for M2 tension left side, and both tensions are equal. Why? Why both tensions are equal? Because string is massless. String is massless, so tension is same everywhere. Okay, note down. Here you write down. Massless means tension is same. Tension is same at all points. Tension is same at all points. Okay, but rope is different. Rope and string are different. What is difference between rope and string? String is massless, but rope is, it has mass. It is heavy. Okay, rope is heavy. Okay, so string means all points same tension, but rope not like this. Different point, different tension. Okay, yesterday we discussed one question, hanging rope. Remember, What is the tension at the lowest point? 0. Tension at topmost point? mg. Middle point? mg by 2. So different point have different tension. Okay, rope, heavy rope. But string means same tension. Okay, fine, good. Now find acceleration. How to find acceleration? So they are combined. So when you combine these blocks, what is the total mass? Combine these two. What is the total mass? m1 plus m2. And what is the external force? F. Tension is internal force. Tension is internal. Okay. Tension is internal. This tension is internal, and this F is external. External and internal we have discussed, right? That car example, correct? Remember car example? Front seat you are pushing. So that is internal or external? Internal, correct, good. So M1 and M2 are one system. M1 and M2 are one system. So the tensions, this T and this T are internal. So they will cancel each other. So what is the external force? F. F is the external force. So you can write now write down to find acceleration. To find acceleration, consider external force. Consider external unbalanced force. Consider external unbalanced force. So what is the external unbalanced force here? F. So F is equal to total mass into acceleration. Total mass into acceleration. So F is equal to m1 plus m2 into acceleration. So what is the acceleration? F by m1 plus m2. Note down. F by m1 plus m2. Acceleration. So it is like a system. Tension force by string on m1 is internal. Tension force by string on m2 is internal. Right, left, cancel, cancel. And this is external. Okay. So fine. So net external force F is equal to ma, total mass into acceleration. So acceleration you got. Now you come to m1. So what is the unbalanced force for m1 only? Only for m1. For m1, what is the unbalanced force? Tension T. Okay. So for m1, unbalanced force is T. Unbalanced force is T. So T is equal to mass into acceleration. Note down. Unbalanced force is mass into acceleration. Newton's second law. Net unbalanced force is mass into acceleration. So what is the unbalanced force here? T. So T is equal to mass into acceleration. What is the mass? M1 into acceleration. What is acceleration? F by M1 plus M2. So what is the value of tension? M1 by, correct, M1 plus M2 into F. This is the formula, tension formula. Okay. So to find acceleration, consider external unbalanced force is equal to mass into acceleration. So for whole system, it is M1 plus M2 and external force is F. So F is equal to M1 plus M2 into A. And only for M1, unbalanced force is T. So T is equal to M1 into A. Okay, T is equal to M1 into A. So formula for tension is M1F by M1 plus M2. Okay. Now you check, you answer this question. Force is acting on M1 or M2? M2. What is coming in numerator? M1. Now let's change the situation. This is M1, this is M2. They are connected by a string, and now force is acting on M1. So what is the tension on the string? What is the tension? M2 by M1 plus M2. Good. Into F. When force acts on M2, M1 is coming numerator. M1 here. Now force is acting on M1. M2 is there. Remember this. Into F. Okay. M2 by M1 plus M2 into F. Suppose this is 2 kg, this is 3 kg. So this is 10 Newton force. Tell me, what is the tension? Tension on the string. How will you find tension on the string? Tell me, what I write? Numerator? 2 or 3? 2. Very good. 2 by 2 plus 3 into 10. 2 by 5 into 10. 4 Newton. If force is acting on M2, M1 is numerator. Force is acting on M1, M2 is numerator. Okay. So force is on 3 kg, so 2 kg on numerator. Okay, done. Next is 3 blocks. Note down. There's 2 blocks over. Now 3 blocks. M M is connected to 2M. 2M is connected to 3M. How many strings? Strings. 2 strings. How many blocks? 3 blocks. Now you are exerting force F on M. Find tension on string. Draw this diagram. Connecting M and 2M. This is the question. Start solving. Now you know how to solve. Combine. Which two you will combine for first question? For I want tension between M and 2M. So which two you will combine? 2M and 3M you combine. Okay, do it. Start. Okay. Solve. And tell me your answer. So combine 2 and 3. So you will get 2M, 3M combined, 5M. I want tension between M and 2M. So these two combined. So what is the tension? 5M by 6M. Good. Into F. Okay. Understood? Okay, good. So this is 5 by 6 F. Now to find tension between 2m and 3m, combine these two. So 3m, 3m. Now find tension here. 3m by 3m plus 3m, 6m into F. So 3m by 6m into F. Okay. So answer is F by 2. F by 2. Okay, correct. Good. F by 2. Done. Finish. So two blocks finish, three blocks finish. Now what type of surface? Surface is horizontal, smooth surface and horizontal. Smooth horizontal surface. Okay. Now let's talk about vertical. Now vertical, note down. So how is the motion in this case? How is the motion? Horizontal. Blocks like train moves horizontal. Now let's talk about vertical. Okay, vertical. Vertical means like this. So see, two blocks connected by a string. Note down. Two blocks. Two blocks connected by string pulled up. Pulled up. See, this block is M1, this block is M2. They are connected by a string and you are holding M1 and you are pulling it up. So external force F. This is the case. M1 is pulled up. So it is like suppose there is a building, there is a building and some small kids are there. Okay, they want to go to the terrace. Okay, without staircase, no staircase, nothing. So one very heavy person is there. This person will throw the rope. This student will hold the rope. Okay, then it will pull it. So these two students will look like this. Correct. Now this person is pulling it. So both these students, what they are doing? Holding the rope. And this person is pulling it. Correct. So like this. Okay. So two blocks are there. So tell me. So how many strings? How many strings? One string. Blocks two. And you are exerting force on M1. So this is external force. This is external force. Now what is the combined mass? Combined mass M1 plus M2. So the combined weight, what is the combined weight? M1 plus M2 into G. Combined weight M1 plus M2 G. And what is the external force upward? F. So this is external. Combined weight is also external. Okay. This is external. External. Who is exerting this force? Earth. Gravity. So that is external. but tension force is internal. Tensions are internal. So net unbalanced external force, net unbalanced external force, Newton's second law, net external unbalanced force. One external force is F upward, second external force is combined weight downward. So what is a net external unbalanced force? F minus this, because the blocks are going up. Acceleration of the block is up. So which is greater? F is greater. Like F is maybe 5 Newton, combined weight maybe 2 Newton, okay, like this. So F is greater. So 5 Newton is greater. So, so how to find acceleration? Net unbalanced force. So F minus m1 plus m2 into g is equal to, this is the net unbalanced force. And net unbalanced force, tell me what is this? Newton's second law. Net unbalanced force is equal to mass into acceleration. So what you write? m1 plus m2 into acceleration. Okay, are you getting or not? Note down, note down. Net unbalanced force, net external unbalanced force. Remember, external unbalanced force. I'm not considering tension, because tension is what type of force? Internal. Tension is internal. Okay. This F is external. Like these two small kids, they are a system. This is one system. And you are exerting external force. So this is the external force. And the weight is what? External force. So one external force is downward, another external force is upward. So net external unbalanced, this is equal to mass into acceleration. Okay, understood? Okay, fine. Now draw FBD of M2. What is the upward force? Tension for M2, downward force, M2G. So tension upward, M2G downward, but acceleration is upward. So which is greater, T or M2G? T is greater. So how to find net force on M2? For M2? For M2. Net force, tell me, for M2. What is the upward force? T. Downward force? M2G. So what is the net force? T minus M2G is equal to MA. M2 into A. And A you will find from here. What is A from here? F minus m1 plus m2 into g is equal to m1 plus m2 into a. Now divide both sides by m1 plus m2. So you will get f by m1 plus m2 minus g is equal to a. So what is the acceleration? Now acceleration you got. What is the formula for acceleration? F by total mass minus g. F by total mass, F by total mass minus g. F by total mass minus g. That is acceleration. Now substitute here, you will get tension. Find tension, substitute here. This acceleration you substitute. So T minus M2G is equal to M2A. Now M2 into A. F by M1 plus m2 minus g. Okay. Now simplify this, solve this. So I'm doing here. So T, take m2g right side. So T is equal to m2g plus m2f by m1 plus m2, m2f by m1 plus m2 minus m2g. Once again I will check. So f minus m1 plus m2g is m1 plus m2a. So f by m1 plus m2 minus g is equal to a. So a is equal to f by m1 plus m2 minus g. T minus m2g is equal to m2a. So T minus m2g is equal to m2 into bracket f by m1 plus m2 minus g. So T minus m2g, so T is equal to m2g plus m2f by m1, correct, minus m2g, okay, cancel, this is cancel. So T is equal to m2f by m1 plus m2. Okay, once you check. M1 plus m2 minus g. T is equal to m2. 2 minus m2g is equal to m2a. Yeah, correct only. Okay, so this is the tension force. So this is the tension force. So we can find like this also. For M1 you can write F is acting upward for M1, M1G is acting downward, tension is also acting downward. Now what is the net force for M1? What is the net force for M1? F minus T minus M1G. Okay, you can solve like this also. One more method is there. F minus T minus M1G is equal to M1 into A, okay, mass into acceleration. If you consider only M1, if you consider only M1, if you consider only M2, what you write? Only M2. T minus M2G is equal to M2A. Okay. Now divide these two, this by this. F minus T minus M1G divided by T minus M2G is equal to M1 by M2. Now you find T, cross multiply. Correct only, this formula we are getting. Okay, I'm just cross checking. Okay, so F M2 minus T M2 minus M1 M2G is equal to cross multiply T M1 minus M1 M2G. So this is cancelled. Okay, so Fm2 minus Tm2 is equal to Tm1. Okay, these two cancel. So Fm2 is equal to M1 plus M2 into T. So T is equal to Fm2 by M1 plus M2. So same formula we are getting. Okay, so it is correct. M2F by M1 plus M2. Okay, clear? Note down. So two blocks. Okay, two blocks. There was one movie also. You remember Kalki movie? Kalki, you watched it? Remember? Ah, the climax scene is like this only, right? So, if you remember, in the last scene, two-person fall, right? Remember, one person fell, falling, another person will catch it. Now, two-person falling, third person will catch it. Remember, one person falling, like this catching. Now, two-person falling to third person here, very heavy, huge person catching like this. Now, pulling it, pulling both person. Remember that. So this is that situation only. So this is force F. So that heavy person, that huge person is exerting what force? F. And whole weight of this person is acting where? Down. So what is the acceleration? F minus W is equal to total mass into acceleration. Correct? Done? Finish? Okay. So, so this is the tension. Force, you are exerting force on M1. So tension is M2F by M1 plus M2. And this is the acceleration. This is the acceleration. F by M1 plus M2 minus G. Write in your formula diary also. Okay, these are the formula. Formula, note down formula. Tension on string. Tension on string. Acceleration. So I am giving one question now. Okay, copied. Now write down question. This is 3 kg block. This is 2 kg block and 100 Newton is acting external force. Find tension and acceleration. Find tension, find acceleration. So how many blocks? 2 blocks. Okay, solve. After this, I will give 3 blocks. First you answer. Direct formula, use direct formula. What is the formula for tension? This is M1, this is M2. M2, correct, good. So how much tension? 200 by 5. So what is the answer for tension? 40 Newton. Tension is 40 Newton. Okay. So tension is 40 Newton. And acceleration, what is the formula? F by M1 plus M2 minus G. F by M1 plus M2 minus G. So F by M1 plus M2. M1, M2 minus G. 10. 100 by 5 minus 10. 20 minus 10. 10. So acceleration is 10. Okay, clear? Suppose you want to apply the concept. So here upward force is 100, downward force is tension, downward force is 30 also, weight. So you will write 100 minus T minus 30 is equal to MA. And for this 2 kg, tension T is upward, 2G is downward. So what do you write? T minus 20 is equal to 2A. Now add these two equations. Add these two equations. Minus T plus T cancel. So 100 minus 30 minus 20. 100 minus 30 minus 20 is equal to 3a plus 2a. 3a plus 2a. So what you get? 100 minus 50. So 50 is equal to 5a. So what is the acceleration? 10. Okay, acceleration is 10. Using direct formula also, same thing you are getting. And you apply concepts. Concept also apply. Same answer. Now find tension using this. Find tension using this. T minus 20 is equal to 2a. So T is equal to 40. Okay, 20 plus 20. Okay, so this is a concept. 3 kg, 100 Newton pulling up, tension, pulling down, tension, pulling down, 2 kg, tension, up, mg, down, mg down, tension up. Are you understanding this? What do you call these diagrams? What do you call it? FBD, free body diagram. Okay, free body diagram. Clear? Unbalanced force. Unbalanced force is equal to mass into acceleration. Chalo, done. Okay, so this is the two blocks. Okay, two blocks pulled upward. Two blocks pulled upward. Now I can give three block also. Then you have to combine two blocks. So use the direct formula. So remember both method. This is also important. You have to understand this. For understanding purpose, this is important. But for exam purpose, NEET paper, direct formula. Okay, copied? So note down. Now I will give three blocks. Now three blocks. Three blocks are there. 1 kg connected to string, 2 kg again connected to string, 3 kg. How many strings? Two strings and three blocks. And you are exerting 100 Newton on 1 kg. So let's call this block is A, this block is B, this block is C. So what is the acceleration? So acceleration formula use this F by m1 plus m2 plus m3 minus g. Use this formula, okay? And tension between A and B. Tension between A and B. And the tension between B and C. So when two blocks is there, formula is this. When two blocks are there, this is the formula. Acceleration F by m1 plus m2 minus g. Now three blocks there. This is the formula for acceleration. F by m1 plus m2 plus m2 means total mass. Okay? This is the total mass. F by total mass. F by total mass minus g. So what is the acceleration here? What is the acceleration here? F by total mass. What is total mass? 6 minus g. 50 by 3 minus 10. Solve this. 50 minus 30 by 3. Answer 20 by 3. Or you can say 2g by 3. Okay, fine. 20 by 3. Note down. 20 by 3. Acceleration 20 by 3. Now I want tension between A and B. So combine these two. Tension between A and B. This is A, this is B. So combine B and C. So when you combine B and C, this is 1 kg, Now combine these two, 5 kg. Now this is the string 1. This is the string 1. Understood? This is the string 1. String 1. Then this force is 100. So now what is the tension? Tension formula. What is the tension formula? M2 by M1 plus M2 into F. So 5 by 1 plus 5 into F 100. 500 by 6. Okay. 500 by 6. So this is a direct formula, direct trick, and okay, clear. So acceleration you got, okay, 20 by 3. Now how to find tension between B and C? This is string. This is a string 2. String 2. So TBC, tension between B and C. B and C tension. So combine these two. 1 and 2 combine. So 3. 1 and 2 combined, so 3. Now this is string 2. Then this one, 3 kg. So what is the tension? Tell me. A and B combined. Tension. Tell me. Tension. 3 by 3 plus 3. Correct. Into F. Okay. So 1 by 2 into F. So 50 Newton. So what is tension in upper string? 500 by 6. 250 by 3. Okay. What is tension in lower string? 50. Okay. Clear? So tension formula, acceleration formula. This is acceleration formula. So acceleration is force, external force by total mass minus g. Okay, this is the acceleration. Okay, clear? Understood? So this is also not easy. This is not easy question, remember. This is above easy, average. Average. So high chances there this may come next year. Okay. So, okay, fine. Okay, done. Now pulling blocks over. So now next you write down uh, pulley. Let's come back to pulley. Note down pulley system, pulley and blocks. Pulley and blocks. Yesterday we discussed clamp. You remember? Clamp we discussed yesterday. Huh? Okay. So again clamp will come. So now we are doing pulley and blocks. Again, very important. Pulley is a machine, right? Pulley is a machine, a small machine it is. It is a small metal disc. It is a small metal disc. So let's talk about pulley first. So generally pulley is small. What is ideal pulley? What is ideal pulley? Ideal pulley is small, massless, smooth. Small, massless, smooth, frictionless. There is no friction. Small, massless, smooth. Okay. So no mass is there. Let's take one example. So pulley is machine. It is a small metal disc. Ideal pulley means a small, massless, smooth. Ideal pulley cannot rotate. Ideal pulley cannot rotate. Why? See, suppose this is the clamp, this is the pulley. Now this is ideal pulley. Ideal pulley is what? Frictionless. Ideal pulley is frictionless. Now suppose you are holding it here. If you do like this, it will rotate or not? It will not rotate because it is what? Smooth. Friction is not there. But if it is non-ideal, then it is not smooth, it is rough. So rough pulley, if you exert one force here, so it will rotate. Okay, it will rotate like this. How it will rotate? If you are exerting force here, like this, like this, you have exerting force. So how it is rotating? Anti-clockwise. And if you are exerting force here, it will not rotate because smooth. Okay, so a smooth pulley can rotate or not? Cannot rotate. Rough pulley can rotate. Okay, smooth pulley cannot. Ideal pulley means a smooth, massless, small. Okay, radius is very small. Small means radius is less. Okay, clear? Okay, next, note down. You can draw this diagram, or you can simply write ideal pulley cannot rotate. Okay, because it is smooth. Okay. Okay, next. Let's take one example. You can note down how pulley reduces effort. How pulley reduces effort. Effort means, suppose you want to lift something, so effort is required, means energy is required, correct? I will give one example. It is given in NCERT also. It came in 2022 also, NEET. Okay, so NCERT, it is new, or I think new or old, both it is given. Okay, see, this is how pulley reduces effort. See, this is the ground level, and this is a well. It is a well. Okay. Now there is a bucket of water. This is the bucket of water. Now one person is there. So this is a string, or you can call rope also, no problem. Okay, string. So this person is pulling this string up. So person is pulling A up. Now string is pulled up. So B is also pulled up, and B is connected to bucket, correct? So bucket is pulled up. So find normal force on the person. Find normal force on person. Now mass of bucket is given is m1. Mass of bucket is m1, whole water plus bucket m1, and mass of person is m2. String is vertical. Okay, you are pulling the bucket. So bucket, this is the bucket. What is the downward force on bucket? Downward force m1g. Very good. Upward force tension. Now person, what is the downward force here? Tension. Tension is acting downward for person, upward for bucket. So for person, tension is downward. Mg of person will act where? Weight downwards. So M2G is downward, T is downward. And this ground surface will exert normal where? Upward. So draw this diagram, draw both. So this is free body diagram, okay? Now bucket is pulled slowly. Bucket is moving slowly. Bucket is moving slowly. Moving slowly means almost rest like this, moving slowly. Okay, like this it is moving slowly. Like one insect is there, snail, right? Snail, snail like the antenna is there, snail. They move fast or very slow? Very slow, correct? Whole day they will go here to here only. Correct? Very slow they move. Slow means what? If something is moving slow means what? Net force zero. Something moving slow means what? Net force zero. Forces are balanced or unbalanced? Balanced. Forces are balanced. Forces are balanced. Okay, remember, slow movement is balanced force. Like the bucket is coming slow, it is pulled slow. So they are equal. So what is the relation between these two? So they are equal. Hmm. So T is equal to M1G. Now this is equal to add. So N is equal to T plus M2G. Very good. Now T is M1G. Put it here. So what is N? M1G plus M2G. So normal is equal to M1 plus M2 into G. M1 plus M2 into G. So person will feel more tired, this person, because the normal from the ground is equal to weight of person as well as bucket. Okay. So is there any pulley anywhere? Pulley is not there. Now we'll use pulley. So first you copy this. Okay, better I will draw here only because it is easy to compare. So now we are using pulley. So if pulley is used, this is the well. Now here is the pulley. How many strings? One string, okay? So this person is pulling this end here down. Now this string is going like this. So tell me, and on the bucket, what is the direction of tension on the bucket? Upward. Direction of tension on the person? Upward. Now this is the difference. Okay, correct, good. This is the difference. In this case, what is the direction of tension? Downward. In this case, what is the direction of tension? Upward. Good. And tension is same. M1G. Okay. For this, now tension is upward, normal is upward, M2G is downward. So what is the relation between these three? T plus N is equal to M2G. So what is N? M2G minus T, and T is M1G. So M2G minus M1G. So what is the normal force? What is the normal force? M2 minus M1. Okay, M2 minus M1. And previous case, this case, what is the normal force? M1 plus M2. In which case normal is less? Less. In which case normal is less? Case 1 or case 2? Case 2 normal is less. So person will feel more tired or less tired? Less tired. So normal is less. Normal from ground is less. So person feel less tired. Person feel less tired. Okay. Here more normal. So more tired. Okay. When you stand, suppose there is a small kid, it is standing. Standing. So this kid will tired. It will feel tired. Why? Why it will feel tired? Because of the normal force. Ground is exerting normal force, right? That's why this will experience tired. Understood? So the big person will lift it. Okay? Big person will lift it. Then normal force will be gone. No tiredness will be not there. So more normal force means more tired. Okay? Less normal force, less tired. Okay, understood? So pulley is helping it. Pulley is helping it. Correct? That's why we call it machine. So what is machine? Something which reduces effort. Reduces effort. Anything which reduces effort is known as machine. So pulley is a machine. Okay, clear? So we can, if you install two pulleys, see, now this person is holding this rope. Now two strings are there. Okay, one string, two strings. Okay, two strings are there. So see, very carefully observe. Here tension is T and mass is m1. So what is the value of T here? m1g. T is equal to m1g. Now here T, here T, here also T, here also T, because same string. Understood? Now here T, the pulley is massless. Pulley is massless. So net force 0. Upward force how much? This pulley. Upward force how much? This pulley. Upward force how much? T. So downward force also T only. So here T by 2, T by 2. Okay, clear? So here also T by 2. Now this person M2. So for M2, downward is M2G, upward is T by 2, normal is upward. Now this plus this is equal to this. So N plus T by 2 is equal to M2G. So normal is equal to M2G minus T by 2. No, wait. Here, normal is more here. Okay, wait. Cancel this diagram. Another diagram. Wait. I will draw another diagram. See. Okay, now you see. So what is the tension here? What is the tension here? T. So mass is m1. So what is the value of T? T is equal to m1g. So here T, here also T, same string. This string is same, okay? So here what is tension? T. Then here what is the tension? 2T. Very good. Downward is equal to upward because this is massless. Now here also 2T, here 2T, same string. So here 2T. Now for person, mass is m2. What is the upward force? 2T and n. 2T and n. Downward force m2g. So balance it. So 2T plus n is equal to m2g. So what is n? m2g minus 2T. And T is this m1g. So normal force is m2g minus 2m1g. In this case, you are using one pulley. So what is the normal? M2 minus M1 into G. Now you are using two pulley. So what is the normal? M2 minus 2M1 G. M2 minus 2M1 G. So normal is further decreased. Normal is decreased here. So you are using two pulley. Normal is decreased. So it will feel more tired or less tired than this? Less tired. Okay, because normal is less. Here normal is m2 minus m1 into g. Here m2 minus 2m1 into g. Okay, so this is the pulley. So done. Okay, Newton's laws of motion. Okay, pulley. It is given in NCERT also. Check it. It is very important. Last year, 2022, I think it came. 2022. 2022 or 3, we have to check somewhere. Okay. So which law is applicable here? Newton's first law or second law? Which law? First law or second law? First, first law. Is there any acceleration? No. There it is going slowly. Slowly means acceleration zero. Slow movement means acceleration zero. Forces are balanced or unbalanced? Balanced. Forces are balanced. Forces are balanced. So today we have discussed two blocks, three blocks, string, normal, okay, pulley. Okay, next one more example. You observe this diagram carefully. You have seen this type of question. It is a triangular lift. Triangular lift, or you can say platform, or platform. Mass of this platform is m1. Okay. Mass of triangular platform is m1. Mass of person is m2. Now string is connected to triangular platform here. Now this is the string pulley. It is going over the pulley. The other end of the string is held by person. Person is holding this. Okay. Now question is, what is a normal force here? That is a question. Everything is at rest. Find normal force exerted by triangular platform on the person. Triangular platform on person. Okay. So person is holding. So you give me book, Arihant or Singej, any book you have. It is there in books also. So give me. So it is an exercise. It is there. So everything is at rest. Here, what force is acting? It is a triangular platform. Here, tension will act. Okay, normal force. Person will experience normal force where? Upward. So triangular platform will experience normal force where? Downward. Action reaction. Okay, try this question. So it is there in this. This question is pulley question. Okay, page 276, question 31. The blocks question is there, 32. Okay, we have done this. So 12th question is there. The three blocks are there. See? Page 288, question 12. Three blocks. This also. Question 8. This is 2024 question. Two blocks. This is AIPMT 2015. Okay, three blocks. Okay, so finish this. Page 277, question 38. This three blocks. Okay. Page 255. Solved examples are there. 3 blocks. Vertical motion. Page 247. Solved examples. Now this question here given. Page 244, question 9. This question. Page 244, question 9. So how to solve this? So free body diagram of person. Downward force. Tell me, what is the downward force for this? M to G. Upward force from here, tension. Tension. A normal force also there. This platform, normal force. So balance it. Upward force total N plus T is equal to M to G. Good. Now this is for person. Person. Okay. Now triangular platform. Triangular platform. Tell me, what is the downward force? Triangular platform, what is the downward force? M1G. Upward force here, tension. Okay. This platform exerts normal force on person up. So person will exert normal force on platform down. So this is the diagram. Okay, understood. So how many ends are there? String, how many ends? String. Ends, two ends. One end here, another end here. At this end, string is pulling who? Person or platform? String is pulling who? Person or platform here? Platform, platform. At this end, person. At this end, string is pulling person up. Okay, here. Okay, so platform exert normal on person up. So person exert normal on platform down. Okay. Normal on platform from person. And this is the normal on person from platform. Okay, you have to understand all these things. Okay, understood, clear. So what is the normal force? So T also you find, what is T here? T is equal to N plus M1G. T is equal to N plus M1G. And so now two equations you have. N plus T is equal to M2G and T minus N is equal to M1G. Okay. M1 is mass of platform, M2 is mass of person, M2 means person. Now, if you add these two, if you add NN cancel, 2T, what is 2T? M1 plus M2 G. So what is T? M1 plus M2 by 2 into G. Okay. Now subtract. Now if you subtract this minus this minus this, TT cancel. 2n, very good, 2n, m2 minus m1. So what is n? m2 minus m1 by 2 into g. Okay, clear? So in your formula diary also you write down. So this question, so last 3 4 years not come. Okay, so important, this is for next year, it is important. So note down. So force on the string, force exerted, force exerted, force exerted by string on platform is T, and force between person and platform, force between person and platform is N. Okay, force between person and platform, note down. Force between person and platform. Okay, so this is triangular platform. Okay, this is triangular platform. Okay, understood? And this is the force exerted by string, force exerted by string. Okay, so remember this, force exerted by string, m1 plus m2 into g, and normal force between person and platform, m2 minus m1 into g, mass of person minus platform. M2 means person, so person minus platform mass into g. So person minus platform into g. So let's solve this question. So in this eighth question, page 244, question 8. Page, solve this question. Man of mass 50 g. Actually, that should be weight. What is the weight of man? What is the weight of man? 50 g. Okay. Frame. Now triangular frame. Triangular frame. What is the mass? 30 kg. So what is the weight? 30 g. Okay. Weight is 30 g. So that means m2 is given as 50. m1 is given as 30. For the system be in equilibrium, what force man must exert on rope? What force man must exert on rope? This is rope. Person is pulling rope down. So what is that force? Means what they're asking, T or N? What? T, correct. They are asking T. So what force person exert on the rope? Okay. So T. So what is the formula for T? Now use this. Sum. So m1 plus m2 into g by 2. Okay, clear? m1 plus m2 into g, how much? 80. So 80g by 2. So 40g. Okay. So 40g is your answer. Okay, 40g. Note down. Okay, 40g is your answer. So now uh, remaining question is homework. Okay, now you take this. So okay, you take 15-minute break. Okay, I will continue after that. Okay, take break. Okay, okay, take 15 minutes. Okay, because continuously this is not good.